Hi, so we're going to continue with probability and look at experimental probability and theoretical probability. So let's start with the definition of what these are. Theoretical probability is based on what should happen in an experiment. For example, if you were to throw or toss a coin 50 times, you should land on heads half the time and tails half the time. That's what should happen. Experimental probability is based on what actually happens in an experiment. So let me throw it at you again, throwing or tossing a coin 50 times. Realistically, if you actually did that, you probably would not land on heads 25 times and tails 25 times. So theoretical probability is in theory what should happen. Experimental probability is when you do the experiment, what actually happens. So to find these two, let's talk about finding theoretical. To find theoretical, you just take the number of ways that it can occur and you put it over all possible outcomes, your sample space. So the theoretical probability, you just find it as you would any kind of probability. It's what should happen. Experimental probability of an event is an estimated probability based on the number of positive outcomes to the experiment. To find the experimental probability of rolling a number cube, a 1 on a number cube, you would roll the number cube and see how many times it happens. So experimental probability is when you actually do it. So let's give an example here. A class of 32 students has 18 boys and 14 girls. If one student is chosen to take attendance for the semester, what is the probability that a boy is chosen? So the number of boys is 18 out of 32. So the probability of a boy being chosen is 18 out of 32, or simplified is 9/16. This is an example of theoretical probability. It's what should happen. If they actually were just to choose at random, maybe draw straws or draw a name out of a hat, it might be a boy, it might be a girl, you don't know. But the chances of what it should happen is 9 out of 16 times it should be a boy. Some more examples. Let's try these top two together. If you have 12 coins, they've got 5 pennies, 4 nickels, 2 dimes, and a quarter in a bag. Find the theoretical probability of selecting these. One quarter in one draw. Well, we have 1 quarter out of 12 total coins. Oh, my pen stopped working. Out of 12 total coins. So we have a 1 in 12 chance of pulling a quarter. Number 2 is drawing a penny. Well, the chances of drawing a penny is that I have 5 pennies out of 12 coins. So I have a 5 in 12 chance of pulling that coin. Using the same situation, drawing one dime. Well, we have 2 dimes out of 12 coins, and we do always try to simplify down to 1/6. And 1 nickel to draw. Well, 1 nickel, we have 4 nickels out of the 12, so we have a 1 in 3 chances. So all of these guys were all examples of theoretical. And I want to ask you, why do you think we have only examples of theoretical? Well, the reason why is experimental, you actually have to do the experiment. You would sit there and pull those coins out of the bag and see how many times did you actually get that penny or get the quarter. Would it be 1 out of 12? Maybe. You might draw the quarter 2 out of 12 chances. You just don't know. So experimental probability is really hard to do unless you're doing the experiment, and we can't obviously do that through a video. Excuse me, let's look at one more example. Levon has a bag of candies. There are 20 candies in the bag. There are 6 red, 5 orange, 3 brown, 2 yellow, and 4 blue. Without looking, she chooses a candy, records the color, and returns the candy to the bag. She performed this experiment 100 times and found that she chose an orange candy 22 times. What was the experimental probability of choosing an orange candy? So here's an example of experimental. We did not actually do the experiment, but they are describing what happened when Levon did the experiment. They are saying that they pulled it 100 times. That's all your outcomes. And out of it, she pulled an orange candy 22 times. So we don't worry about what should have happened. We worry about what actually happened because it asked for the experimental. She pulled it 22 out of 100 times, which that would simplify to 11 over 50. So our answer here is C. That is the correct answer. That's the experimental probability. You go based on what actually happened when LaVon did this. She did it 100 times, and she got the orange candy 22 out of those 100 times. So that's a really good example of showing you the difference between those. Now, what we could say here is what should have happened, so you can see the difference between the theoretical and the experimental. So going up to, she has 20 candies in the bag, and out of those 25 of them are red. I'm sorry, 5 of them are orange. If she were to do this 100 times, how many times would she actually get an orange? Well, we can solve this by using cross products. I could also solve it by just doing equivalent fractions. I multiply by 5, I multiply by 5. She should have pulled an orange candy 25 out of 100 times. That is the theoretical probability. What actually happened when she did it was she pulled an orange candy 22 times. So very close, but that's a really good way for you to see the difference between experimental and probability and experimental and theoretical probability. Good luck.